Did you know there's a hidden language that shapes the entire world around you? A language of space and shape and design? Well, there is, and it's the language of angles. And today, we're going to learn how to speak it.
Seriously, once you know what you're looking for, you start to see them absolutely everywhere. They're in the buildings we live in, the technology we use, even in something as simple as a clock. And you know what? That's the perfect place to start.
Okay, take a look at 1 o'clock. See that little space between the hands? It's pretty small, right? Kind of sharp. Just hang on to that mental picture for a second.
All right, now let's jump to 3 o'clock. Now this shape, you've seen this a million times. It's that perfect corner. You know, the corner of a book, your TV screen, or a room. Just think about it. How many of those perfect corners do you see every day? Probably hundreds.
So what happens when the hands get even wider? Look at this. The space is much bigger now. Way more open. It's definitely a different vibe from the first two we saw, right?
And for our last example, check out 6 o'clock. The hands make a perfectly straight line. And get this, that is also a type of angle. So what's going on here? What even is an angle, really?
Okay, so here's the official definition. An angle is basically just two lines, or rays, that meet up at a single point. That point where they connect, we call that the vertex. So an angle is really just a way to measure the space created where those two lines meet.
So now we know what they are, but how do we measure them? Well, we use degrees. And that, my friends, leads us to a really cool ancient mystery. Why on earth 360?
No, I'm serious. Think about it. We count in tens for pretty much everything else. So why is a circle chopped up into 360 parts? It feels totally random, doesn't it? Like 100 would make so much more sense.
Well, the answer has nothing to do with modern math. To figure this one out, we have to go way back, like over 3,000 years back, all the way to ancient Babylon.
So here's the deal. The Babylonians didn't use a base 10 system like us. They used a base 60 system, and they calculated that the year was about 360 days long. So to track the sun's journey across the sky, they divided a circle into 360 parts, one step for each day. The Latin word for step is gradus, which is where we get the word degree. And we're still using their system today. Wild, right?
Okay, so now that we know why we're working with 360 degrees, we can finally give proper names to all those different angles we saw on the clock. It's time to meet the angle family.
First up, we have the acute angle. These are any angles less than 90 degrees. An easy way to remember it? It's a cute little angle, small and sharp. Next to it is the famous right angle. This is your perfect corner, and it is always exactly 90 degrees. No more, no less.
Now, if an angle is bigger than a right angle, we call it an obtuse angle. That's anything between 90 and 180 degrees. And remember that straight line from the clock at 6 o'clock? That's a straight angle, and it clocks in at a perfect 180 degrees.
Oh, but we're not done yet. There's also the reflex angle. This is the big one on the outside. Imagine opening a door so far it swings way past a straight line. That's a reflex angle. It's between 180 and 360. And finally, if you go all the way around back to where you started, that's a full angle, a complete circle, all 360 degrees.
All right, so it's one thing to know all the names, but how do we figure out the exact measurement? Like, is an angle 58 degrees or is it 62? For that, we need a very special tool. Meet the Protractor. It's basically a half circle that's marked with 180 degrees. Now, you'll probably notice it has two sets of numbers, one on the inside and one on the outside. That's just to make it super easy to measure angles, no matter which way they're pointing. Using it is super easy. It's just 3 steps. First, you put the little center point of the protractor right on the angle's vertex. That's the pointy part. Second, you line up one side of the angle with the 0 line. And third, you just look where the other side crosses the scale. That number? That's your angle. Simple as that. And drawing an angle is pretty much the same thing, just in reverse. You start by drawing one line. Then you put your protractor on the endpoint, find the degree you want on the scale, and just make a little dot. The last step? Just connect that dot back to your starting point, and boom, you've drawn a perfect angle.
You see, learning this stuff isn't just a geometry exercise. It's like getting a new lens for your eyes that literally changes the way you see the world. The great astronomer Galileo basically said it best. Geometry is the hidden language of the universe, and angles? Well, they're the alphabet. Remember when we started? We were just looking at a simple little diagram like this one, just 2 lines meeting at a point.
And it's just amazing to think that this one simple concept is the building block for, well, for everything. All the beautiful, complex things we see around us every single day.
So, I'll leave you with this question. Now that you speak this hidden language, what new patterns and what new structures are you going to see in the world today?